All right, getting back into it. Next thing we're going to do is basically a glossary of ocean terms that you're going to come across as you debate and enjoy this topic. And these are terms that are not just like random vocabulary words. I don't mean that when I say glossary. I mean these are issue areas. These are things that will be affirmatives on this topic most likely. And so there'll be things that you should know something about, be appraised of, have a little bit of an understanding of at the very least. So beginning from the very top with some environmental terms related to the oceans. The first is MPAs, MPAs, which stands for Marine Protected Areas. Marine Protected Areas. Marine protected areas are basically like parks in the ocean. It's just like how we have a national park and you're not allowed to do anything on it except for maybe camp or take some pictures of birds. MPAs are like that, but in the ocean. This will be a core affirmative on this topic and was on the last oceans topic that happened a decade ago. It was an affirmative that I ran very briefly. The idea with marine protected areas is to have some areas that are protected from people fishing or from people building things. And so they basically allow safe havens for ocean environments to thrive and do good, happy ocean environment things without getting interrupted or destroyed by commercial or economic activity. So the idea with MPAs is mostly just to protect the environment. There are also people who say that marine protected areas are a good solution to places where there are conflicts over ownership of an area or an island or a piece of sea. It's just like, well, if we can't decide whose ocean this is, maybe we should just make it a park. There are people who advocate that in terms of like, the Bering Strait was one place that I've seen where someone says we should make a park out of that. So that's MPAs. I've already mentioned coral reefs and the Great Barrier Reef. The Great Barrier, yeah.
What made you stop writing the MPAs?
A different F.
Oh.
Decisions a decade ago. Yeah.
Aren't you basically saying that they are protected from development?
Yes, which is why I think there will be a T debate. But given what we were saying about development is just improving an area for a specific purpose, if I am developing some buoys around an area to improve it by allowing the natural environment to thrive, I've taken an undeveloped spot of ocean and made it into a park. So I think you could argue that I have developed something. Again, but I think you're right that negatives will have a pretty decent topicality argument that that's not economic. Yeah.
Can you have an MPA within one's territorial waters?
We'll talk about territorial waters in a little bit, so table that. Yeah, that's a whole different issue. Coral reefs, specifically the Great Barrier Reef. The Great Barrier Reef will come up a lot because it's kind of amazing. I already mentioned that there's a lot of life going on there. It's basically one giant chunk of things that are alive that's the size of England, and that's fairly impressive. There are also all sorts of arguments as to how better research of Great Barrier Reef corals and organisms can provide cures to various diseases. One of the things I read about just the other day was that scientists have found a way to use some of the way that coral works to build itself up. Because coral it's an organism, but it can make itself as strong as rock. It can kind of build itself into a chunk of something. So scientists were using the way coral grows itself to try to grow human bones, basically. Shaped human bones out of coral in order to design those organically and on their own. That's just one small example of the reason why people say that a better understanding of ocean life can advance medicine a lot. If we research the Great Barrier Reef, we might know more about coral, we might know more about organisms, we might know more about how they interact with one another and with us, and we might be able to develop better medicine. There are also, of course, people who say that without reefs, like the Great Barrier Reef, where aquatic and marine life tends to center, that things would go south for the global environment in a real hurry. Next term is aquaculture. 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 I don't know. I like it as aquaculture, so I'm going to say it like that. Aqua or aquaculture, if we must, is basically fish farms. We have areas that are set off in the ocean where you can basically try to breed new fish or try to maintain steady fish populations. People propose aquaculture as a solution to the next term, which is overfishing. Overfishing is exactly what it sounds like. We are eating more fish than fish are being made by other fish. There are not enough fish for us to eat. And so we have overfished certain species of fish. There are some types of fish that you can't really get anymore or are prohibitively expensive to get, and you can only get in certain luxury situations because we've eaten so many of them. There are people who hypothesize that you will not be able to get tuna within a couple decades. There will be no more tuna because we will have eaten too much tuna and the population will need to come back. And so overfishing is when we fish too much. Aquaculture is basically fish farms in the ocean. And there are a bunch of different types of aquaculture. There's on-land aquaculture. That's probably not a thing we'll be talking about. There's like open ocean aquaculture, where you just sort of say, like, in this area, these fish are probably going to hang out, and so, we'll try to protect and manage this. But aquaculture is basically applying agricultural principles of growing food to fish and to the ocean. Trawling. Trawling. Trawling, not to be confused with trolling. Trawling is a fishing technique that involves drag nets that scrape the bottom of the ocean floor. Basically, the way trawling works is a boat will go out, they'll drop a net, that net will go all the way to the bottom of the ocean, and then they'll just drag that sucker across. The reason why people like to do trawling is that you can catch all of the lobsters and scrimps and all sorts of other delicious things, and also all kinds of fish. The reason people dislike trawling is that it's really nasty for the environment, because it's something that, because you're just dragging a giant thing across the bottom of the ocean, if there's stuff that's alive on the bottom of the ocean, like coral, it's probably going to get crushed or destroyed by trawling. And so there are a bunch of regulations that exist now that attempt to prevent trawling. It is very difficult to enforce those regulations, because in order to enforce those regulations, you sort of have to drive a boat 200 miles off the coast to another boat and say, like, are your nets touching the ground? And so that's not really something that's easy to enforce. It's something that's largely illegal in most contexts, but it's something that will come up on this topic. Next term is Keystone Species.
Great.
Keystone Species. Does anyone want to take a stab at what a keystone species is? Yeah.
It's when you take, well, usually a certain type of species of something, and if you take it out of the ecosystem that it's in, the entire environment collapses.
Right, exactly. Keystone species is a theory that biologists have about the way ecosystems work. So the way ecosystems work, you'll have, some species eating a different species, which eats a different species, which has a parasite on it, which hangs out with a different species, etc. Scientists say that there are certain keystone species, that there are things in ecosystems or species in ecosystems that we cannot do without. The term comes from architecture, where if you look at an arch, the thing in the middle of the arch, that's the keystone. And that is a very strong stone. It holds everything together. If you take that out, the whole arch just collapses. And so the argument with keystone species, and you'll see this come up a lot whenever there's a discussion of an individual species, is that some of them are really important to the ecosystem, and if we run a certain individual species extinct, we can destroy an entire ecosystem worth of species, because they will no longer be able to survive and thrive. People make this argument about various types of turtles. I've seen this argument made about blue horseshoe crabs, and all sorts of other things. People say that a whole variety of things are keystone species, species that we simply can't do without because if they weren't serving their function in an ecosystem, if no one was eating the smaller fish, for example, then maybe the smaller fish would eat up all of the plankton, there'd be no food left for somebody else, everybody would die, it'd be sad. Next other set or type of species is invasive species. Invasive species. Invasive species is a term for a species that is not native to an ecosystem. Species that is not native to an ecosystem. So invasive species weren't really that much of an issue before global trade started happening. So once we started having boats going to and fro everywhere, invasive species became a much greater issue because a certain type of algae might be stuck on the hull of your tanker, and that type of algae might exist in the Gulf of Aden over near Africa, but might not exist in the Gulf of Mexico in the United States. If you bring that new type of algae in, it can have weird effects on the existing ecosystems that are going on right now, and those effects can be really bad and really damaging. An anecdote about invasive species. I had a friend who had a lake house, and on that lake that they lived on, they were having a really big algae problem. In order to deal with the algae problem, they decided to introduce this non-native type of carp. And they were like, these carp, they're going to eat all of the algae. The carp then ate all of the algae, like literally all of it. So all of the other fish started dying because there wasn't enough algae for the other fish to eat. And so what the people managing the lake said was like, oh, I know how we can deal with this. We can put in a type of fish that eats the carp. We're just going to put those fish in. So they got a different type of fish to eat the fish that they got to eat the algae. And of course, the fish that they got to eat the fish that they got to eat the algae ate both the fish they were supposed to eat and all of the other fish. And so then there was no other fish for them to eat, so they all died. And so in order to get rid of some of the algae, so it was easier for people to drive their boats, they killed all of the fish by having fish killing other fish and bringing in other fish to kill fish. This was an intentional introduction of invasive species. They did that on purpose. Now, imagine those sorts of processes happening by accident. This is what happens when we accidentally introduce species into a new ecosystem, and they end up thriving and doing really well. Does anyone know what kudzu is? If you live in the South, you know what kudzu is? Kudzu is not native to here. Kudzu does not belong here. Kudzu was imported because it was thought it was maybe like a good fibrous material that we could use for like fabrics or something, or as a fuel source. But then we were like, this stuff's not that useful. But then it just started growing everywhere. And because it was not native to the ecosystem, it had no natural predators, there was nothing that had evolved to eat or kill it, and so it just dominated everything else. And so you'll see whole forests that are just overtaken by kudzu. This is analogous to what happens in some marine ecosystems if invasive species get introduced. It's something that folks are very concerned about, particularly with international trade. There are suggestions that we need to have ways to check the outer hulls of ships, or basically sanitize them, to keep invasive species from getting in. Coastal wetlands. Coastal wetlands. Coastal wetlands are just something that will come up in your research because they're very important areas to the environment. There's a lot of species that live there. There are people that argue that coastal wetlands are especially important because of the role they play in the transfer of fresh water from rivers into the oceans. And that transfer has an effect on the general water quality and hydrological cycle that occurs, which we'll mention that momentarily. The hydrological cycle. I already mentioned the hydrological cycle, so I don't really want to get too far into it, but it's basically what water does, the life cycle of water. Starts in the ocean, becomes clouds, clouds become rain, rain goes into rivers, rivers go into the ocean. Now, there are things that matter for the ocean at all parts of that cycle. So, when rain falls, if there's a lot of air pollution in the air, it might affect what is in the rain. You might get acid rain. You might get rain with some particulate matter in it, which affects the agriculture that the rain has fallen on. Might mean we need to put more pesticides in order to have things grow, which means that when that runs off and goes downriver, there might be a bunch of pesticides in that water, and when that gets back into the ocean, then there's a bunch of acid rainy pesticide water that gets dumped into the ocean, which leads to what's known as ocean dead zones, which are basically areas where nothing is alive anymore because we've dumped too much poisonous stuff. Biologists have basically mapped out, if you look outside the Mississippi Delta, like south of New Orleans, where the Mississippi lets out into the Gulf of Mexico, there's a substantial dead zone where life basically cannot exist because there's too much agricultural runoff that exists that goes out there, and it messes with the ecosystem. So those are all parts of the hydrological cycle that you'll talk about as the year goes on. Deep sea vents. Deep sea vents. I mentioned that 90% of volcanic activity is under the ocean. Deep sea vents are a pretty good example of this volcanic activity. They're basically places in the super deep, super dense, super dark ocean where there is some amount of volcanic activity, and that amount of volcanic activity creates a pocket of warmer water, and that pocket of warmer water supports really weird and really unique sorts of life. There's things that live near deep sea vents that glow in the dark naturally. There's things that live near deep sea vents that are just tiny little biological, like algae-like organisms that we don't really understand, and we don't really know very well what they do. And so, I don't know if you had a question. So the issue with deep sea vents is that we don't really know a lot about how they work. They potentially have a lot of life that is interesting, and they are also discussed as a potential energy source because they're a source of heat, and all energy sources ultimately come down to a way of turning a turbine, which we'll talk about momentarily. So deep sea vents are another place like barrier reefs where there's just a lot, and coastal wetlands where there's a lot of biological life happening. Some terms about global warming that will be important to this topic. Global warming. Global warming or climate change. Climate change might be the more preferred term these days. Will can tell you about that more likely, given that he wrote his dissertation about these sorts of things. But climate change and global warming is an issue that will be central to most of the debates we end up having on this topic, or at least a very lot of them. It has a lot to do with energy, it has a lot to do with the environment, and it has a lot to do with society and how we will continue to live and how we will continue to survive, and if we will continue to survive. And so global warming is incredibly important. The ocean plays a big role in that. A few ways in which the ocean plays a role in global warming. The first is with its currents. Its currents. The North Atlantic Conveyor is a current you might hear about as you read about global warming. The North Atlantic Conveyor is basically a transfer of warm water from the south to the North Atlantic, and that warm water from the Gulf of Mexico and from the south to the North Atlantic meets some cold water. Warm and cold water have different densities, and so they sort of interact in a weird way, and it creates an ocean current that basically allows North America and Europe to remain relatively warm and temperate. Climate scientists say that if this current didn't exist, then North America and Europe would be tundras. They would be icy wastelands. There are also people who argue that this current will cease to exist if the ice caps keep melting. Because if ice caps melt, that puts basically fresh, unsalted water into the current, which has a different density than the normal salt water that exists, which messes with the currents because of science reasons that I don't entirely understand, but would shut down that current and therefore totally change the way our environment and our ecosystem and our climate function.
Wait, wasn't that like the thing? Wasn't there like a study done that said like that a temporary shutdown of the North Atlantic Conveyor like could have been the cause of like the colder temperatures that led to the potato famine in Europe? It's like a.
Yeah, there are people who argue that that's like the reason why we had the Little Ice Age. That was back not too long ago when it got colder. That could have been an effect of the North Atlantic Conveyor. People have all sorts of theories as to why it matters. The point is that it matters, and there's no real avoiding. Another term related to warming that is relevant is albedo effects. Albedo, A-L-B-E-D-O, albedo. Does anyone want to take a stab at what an albedo is? Sure.
How light is reflected or absorbed.
Yeah, exactly. An albedo effect is about how much light gets reflected and how much light gets absorbed. Now, most of our primary energy source for our climate is the sun. The sun makes things happen. A lot of times when people talk about global warming, they're talking about our interaction with the sun. Water is a heat sink. The sun hits the water warms up. This is pretty straightforward. Ice, on the other hand, doesn't really absorb as much sunlight. Ice reflects sunlight. So ice has a higher albedo effect. It reflects more sunlight. Clouds reflect sunlight. Oceans do not very well, but ice does. The reason why this is relevant is that as ice caps melt, and scientists are pretty much all on board at this point that ice caps are shrinking, glaciers are shrinking, that as that happens, less light gets reflected back up, less energy gets reflected back up, more energy gets stored in the ocean. The oceans get warmer, which means that's one of the primary ways that global warming or climate change happens, is that the oceans get warmer because there's less sunlight being reflected back up by ice. So you'll see discussions of albedo effects. So any questions about those climate-related things? All right. Let's talk about energy. Energy is something we use a lot of, and we use it for everything. We are using a lot of energy right now for our laptops, for our air conditioning, for these lights. The United States is, per capita, by far and away the most energy-using country. For each individual person, we use so much more electricity than anyone else, and it's not close. And so it's something that we need, or maybe we don't need, but we need at least a substantial amount the way society is operating right now in order to power our economy, in order to live comfortably, in order to have technologies like refrigeration that enable us to store food for longer. All of these things are very, very, very energy intensive. The issue is that there are limited energy sources. There's demand that far exceeds supply for energy. Where does most of the United States' energy come from? What energy sources do we use? Yeah. Fossil fuels, yes. Which fossil fuels? Yeah. Mainly coal. Yeah, we use a lot of coal in the United States. Yeah. What else? Yeah. Oil. Yep.
Natural gas?
Natural gas. Coal, oil, and natural gas are the primary sources of energy and electricity in the United States: coal, oil, and natural gas. Pop quiz for anyone. What is most of Atlanta's power provided by? How many Atlanta people? Yeah. Coal. Yes. Almost all of our electricity is provided by coal. The largest coal plant in the country is actually not too far north from Georgia, or not too far north from Atlanta. So we need a lot of energy, and we need to generate a lot of energy. Now, the thing that natural gas and coal and oil all sort of have in common is that you can burn them. And you burn them to create heat, and you use that heat to make steam, and you use that steam to spin a turbine, and when you spin that turbine, you can create electricity. It's the basis of how energy generation happens. And so most forms of energy generation are trying to find either a way to generate heat in order to create steam to spin a turbine, or a way to simply spin a turbine and skip the creation of heat step. And so all energy creation comes down to that. Now, because we have limited ability to extract oil and natural gas, and because we have limited ability to extract coal, they are fossil fuels, there is a finite amount of them, and because there are environmental consequences to those, a bunch of people argue that we need new and different fuel sources. A bunch of people also argue that we just need more oil and natural gas, and that the ocean can provide us that. So going through some different ocean energy technologies and talking about what they are, I think, is incredibly important, because so many of the debates we have will be about what sort of energy we get from the ocean. The first one, OTEC. O-T-E-C, OTEC. OTEC stands for Ocean Thermal Energy Conversion. It is a proposal for power generation, basically, that says we will use the heat differences of various levels of the ocean. At the top of the ocean, it's warm. At the bottom of the ocean, it's cold. Pretty straightforward. There's more sun at the top than there is at the bottom. The idea with OTEC is that you would pump a small quantity of hot water down to the bottom of the ocean, at which point it would then go back up, because hot water rises, cold water sinks. Or it might be vice versa. They might pump cold water up and it goes down. But basically you do this within a set of tubes, and that turns a turbine. And that would create energy simply using the fact that the sun makes the top of the ocean warmer than the bottom of the ocean. There are people who say that this would be an energy sort of technology that would be incredibly useful, that would solve all of the world's problems, that would create new cool environments for fish to live in, because they could hang out near the OTEC tubes and everything would be fine. It would be a totally clean source of energy. So this will be an affirmative that will be popular on this topic, I think. Just building some ocean thermal energy conversion stations or something like that. Geothermal energy. Geothermal energy is a little trickier to do underwater, because the idea with geothermal energy is just like geo from the earth or rocks, thermal, heat. It's basically saying instead of burning oil or burning coal to turn a turbine, we'll just find something that's hot and have that create steam to turn our turbines. So there are suggestions that with deep ocean vents or with deep ocean volcanoes, you could potentially harness some of that natural heat and energy, of which there's lots, and turn that into electricity. Some countries have had a lot of success with geothermal energy, like Iceland gets the majority of their energy from volcanoes, basically, but they have a lot of volcanoes on land, so it's a little easier for them. So this is a little more fringe, but it's still worth discussing. Tidal energy. Tidal energy. The ocean has tides. Thanks, the moon. It has high tide and low tide. Those tides involve the movement of massive quantities of water. Massive, massive, massive quantities of water. The idea with tidal energy is that if you built barriers to the movement of that water, much like building a dam. In a river, you could harness those tides, which you know every day there will be high tide and low tide, and you can harness that movement of water to turn a turbine and create energy and electricity. A lot of people say the problem with this is that it would require building giant seawalls of tidal energy, basically like fortresses, which wouldn't entirely be pretty for people to look at, but there are some people who say, well, this is the best possible energy source we have because it is powered by the moon going around the Earth, because that's what makes tides work. And the moon isn't going to stop going around the Earth, so it's an energy source that we can rely on going forward. It would provide us with a lot of energy. So some people will talk about tidal energy. Similar, but yeah.
Will it disrupt coastal environments because of that kind of like brick wall?
Yeah, oh, for sure. Yeah, it would definitely, people complain about the idea of a lot of these energy sources because a lot of them would mess with the environment a fair amount. Like OTEC, you could probably do, and it would help the environment a little bit because it's just like some tubes and a pump. It's not terribly complicated, but if you're building a giant wall in the ocean to harness tidal energy, it would mess with aquatic life for sure. But then there's the debate becomes, is it worth it to have cleaner energy sources and less chance of global warming to kill some fish habitats? That'll be a debate. I don't know. Tidal energy, we said tidal energy. Wave energy is similar to tidal energy, but is more reliant on being a little closer to the coast and harnessing the cycle of waves. So waves, basically, the ocean kind of goes in a circle like this toward land, and then as land gets further up, some of that circle comes above water. That's all waves are. And so the idea with wave energy, you harness that sort of circular motion of the tide rolling in, very similar to tidal energy, not all that different. Wind energy. We have a wind app. That'll be the affirmative that probably all of you are having debates about in a couple of weeks, so it's worth discussing a little bit further. There are a lot of proposals to increase the amount of wind power that exists in the United States because it's free. The wind blows, we get energy and electricity. It just simply turns a turbine. We don't need to burn anything. It's perfectly clean. It's great. There's one problem with doing wind energy on land. Anyone think of what that is?
The wind is inconsistent.
The wind doesn't always blow. There's also, it kills a bunch of birds probably. But the one primary problem is that the wind doesn't always blow. So if you're saying my business, my ability to refrigerate food and medical supplies, relies on the wind blowing that day, people say, well, that's not great. We don't really think that that's terribly reliable, and we don't have great ways right now to store leftover energy from days when it was really windy, because our battery technology just really isn't very good, which will be the counterplan that we have will basically be to increase battery technology, and you'll talk about that in your labs. And so the problem with wind is that first of all, it has to be near to a city to be effective, because the longer you build a line to transfer electricity, the less electricity actually gets through the line. There's just kind of attrition as electricity goes on and goes forward, which means that even if there are places where it's good to build wind plants, those places aren't necessarily near cities. There are arguments that the amount of wind that exists in northern Texas and Oklahoma could power the entire country if the entire country were right next to northern Texas and Oklahoma, which it's not. No one lives there. And so there's no real ability to harness that energy and to harness that electricity. Offshore wind, which is what our affirmative is, resolves all of these problems, supposedly. Resolves all of these problems. The wind always blows on the ocean. The wind never stops blowing on the ocean. That's why you can sail boats on it. For the same reason that there are always currents, there are heat differences in the ocean, there are pressure differences, there is always wind. The wind is much more consistent, so you don't have that problem where, well, the wind's not blowing, I guess I'm not going to work today. because I don't have electricity to power my computer. So the wind always blows, or at least blows most of the time. The other reason why offshore wind has a lot of potential is that, remember when I said that 75% of the world's major cities are on coasts? And remember when I said one of the main problems with wind is that you can't transmit the energy a very long distance? If you're generating the energy right off the coast in an offshore wind farm, then it's much easier to transfer it to land. If we just put a bunch of turbines outside New York City, out on the ocean, then maybe we could generate a lot more energy a lot more cheaply, and have that energy be clean and safe and consistent and good. There are some problems that people have with offshore wind as well. A lot of these are technical concerns about who develops it. A lot of these are concerns with, there was a proposal recently to basically build a bunch of offshore wind turbines in Maine, and the people in Maine were like, but that will make our yachts look uglier. And we don't want our yachts to look ugly, and therefore, because our yachts need to look pretty, you can't build those windmills there. Because they're ugly. They're like giant aluminum, huge things. They're not exactly beautiful the way we think of those things. And so there are a lot of people who are just like, they're ugly, we don't want them. But, you know, that's a concern. And then there are concerns with any of these energies about which energy. So we use a finite amount of energy. If we generate more wind energy, it would mean we would use less of something else. We would use less natural gas or coal or nuclear or oil, which means that there are also a lot of concerns from the oil and gas lobby and industry. They don't want us to develop offshore wind. They want us to keep drilling for natural gas, because if we develop offshore wind, we probably wouldn't need as much natural gas, and they wouldn't make as much money. So with any of these energy issues, there are always trade-offs between different energies. If we started using all tidal energy, then what would that do to the parts of our economy and the parts of our country that rely on coal mining as their primary vocation? Probably wouldn't be a great thing for them. And so that's something that's worth discussing. Any questions about wind? Since that's a big deal. Yeah.
Wouldn't we have to build a ton of turbines to generate the same amount of energy that we get from coal and oil?
Mm-hmm. Yeah. But, you know, the F has the power.
Takes up way more space.
You can say develop a ton of turbines. Yeah, the space issue is one that is maybe less concerning, because you can just have like basically a floating platform that goes way up and has a windmill and it's not really in the way of anything, because the ocean. Yeah.
Couldn't you have the same concept with like solar panels?
Yeah, but the issue, I think the issue with that is that for many of the same reasons that the wind blows in the ocean, it's often cloudy. And so I think it's just like for wind power, the problem is what about a still day? For solar power, the problem is what about a cloudy day? Putting wind offshore resolves the still day problem. Putting solar offshore doesn't necessarily resolve the cloudy day problem. So, you know, it's conceptually, and someone probably will do it. And really, all OTEC is just like turning the ocean into a giant solar panel. So you're just using heat from the sun to power a pump. And so, yeah, it's definitely a thing. Any more questions about wind? All right. The other two types of energy we'll talk about are drilling for oil and drilling for gas. Drilling for oil and drilling for gas. Both of these things happen a lot near the United States. There are people who argued that they need to happen more because there's a lot of energy stored under the outer continental shelves and in the Gulf of Mexico and in the Arctic. There are some people that argue it needs to happen less because, as we saw with the British petroleum rigs, sometimes they explode and that does really nasty things to the environment. And so there is a very lively debate that is occurring in the literature about whether or not we should step up offshore drilling or do less offshore drilling, whether or not we should regulate it or leave it a little more unregulated and let people kind of do what they want. And so there will be a lot of arguments and a lot of affirmatives about drilling for oil and gas. The main places where this would happen, the Gulf of Mexico, we already do a lot of oil and gas drilling and exploration there. But the other one you'll hear about is in Alaska on the Arctic shelf. There is a bunch of oil and gas, and there are a whole bunch of reserves up there that are basically sort of in a park right now. There is a wildlife reserve, the ANWR, A-N-W-R, Alaskan National Wildlife Reserve. And that wildlife reserve and the land offshore, it's not legal to drill for oil there, for the most part. So there will be affirmatives that say, we got to drill for oil there, and we'll get that done. There'll also be affirmatives that say we need to drill for gas. Drilling for gas and drilling for oil is sort of different issues and different problems, because one comes in liquid form, one comes in gaseous form. Oil is used mostly for transportation. Natural gas is used mostly for electricity generation. So oil is what makes the gasoline for your car. Natural gas is what provides the heat for your house normally. Is sort of like the distinction that operates. So there are different purposes for oil and gas as well. And so those are worth knowing about. Another thing that is worth mentioning in all of this discussion of drilling is methane hydrate. Methane hydrate. M-A-T-H-A-N-E-H-Y-D-R-A-T-E. Methane hydrate. Methane hydrate is methane, which is a gas, most likely known as fart, that is frozen, and it is under the ocean. Methane hydrate is frozen under ocean fart, sort of, mostly. The reasons why methane hydrate matters are multiple. The first is that it is a very, very, very nasty, methane is a very, very nasty greenhouse gas, which means it contributes a lot to global warming if it gets released into the environment. Other reason why it might matter a lot is that it's potentially a very clean burning energy source. You can burn it, and you can create fuel. The reason why this is relevant is that there's a bunch of frozen ice methane hydrate under the ocean floor, under the outer continental shelves, and it's just sort of like sitting there. Some people say that it's leaking a little bit, and that we need to get it out of there before it leaks, because the more it leaks, then the more likely there will be global warming, because methane is, you'll hear people talk about CO2 in terms of global warming, carbon dioxide. Methane is, I think, 4 to 10 times worse than CO2 in terms of the climate effect that it has, and so it's some nasty stuff if it gets up in the atmosphere. But if you burn it, it's not as bad. Yeah.
Wouldn't it leak more if we tried to extract it, and why would it be a clean burning source if it's such a nasty greenhouse gas?
It's different chemical than burn.
Yeah, it's basically there would be less, because it naturally just floats up in a gaseous form. That natural gaseous form is way worse than the like byproducts of burning it. Similar to, it's not a clean fuel, similar to like natural gas being cleaner to burn than coal. It's a cleaner fuel. But yes, as to your first point, people make the argument that, yeah, trying to drill for it would be real bad because we'd release more. There are people who make the argument that trying to drill for it is good because we have to get it out. One of the concerns that exists with methane hydrate is what's known as methane burps. It's all sitting there in an ice form under the ocean floor, but if the things we said about warming are true, the things we said about ice caps melting are true, and the ocean getting warmer in various places, that might melt some of that ice that this methane gas is in the form of. And when it melts and is no longer in ice form, it bubbles to the surface, or maybe erupts to the surface. There was a theory, basically there was a period of global warming where the Earth became basically unlivable, called, you don't need to know this, the Paleocene-Ecocene thermal maximum. It was about 55 million years ago. It was like as hot as the Earth ever was. The reason people say we reach that point, or some climate scientists theorize, is that all of a sudden a lot of frozen methane went up into the atmosphere and created very sudden and very drastic global warming. So people are concerned about methane under the oceans because if it all bubbled up very suddenly or all at once, then it could be absolutely devastating or disastrous. I remember when someone asked the question earlier, why did I stop reading the Marine Protected Areas app? It's because I was reading a methane app instead. We had evidence that talked about how if there was a giant methane burp, one person lighting a cigarette could create an explosion that blew up the entire world with the force of thousands and hundreds of nuclear weapons, because it's a very flammable gas. And if a bunch of it came out of the ocean all at once and somebody lit it on fire, it would blow up real good. And that might be bad. Yeah?
Is methane hydrate in every single ocean?
I can't answer for sure. I know the places where it's most concentrated or most talked about are like in the Arctic oceans under those ice caps, because it's got to be in a frozen form. Yeah.
How did they get there? How did the methane ice cap things, how did they get there?
How did you get here?
So you tell me it was
I don't actually know. That's a geologist question.
It sinks up from the ocean floor and then it freezes on the way up.
Oh,
So
okay.
it's
Yeah,
pressure.
it's in the center of the Earth, and then because it's cold and high pressure at the bottom of the ocean, it freezes. Boom. Thanks, Will. Yeah.
Are there people who think about like I guess I don't know how to get the methane hydrate, but however it is that they get it, they think of it as like a valid solution to like energy problems, or is it like pretty crazy?
That would be a fringe opinion. There are people who write that we need to develop, our methane hydrates here because we have a lot of them and they're a potentially good energy source. But I think that's more of a fringe opinion because, one, they're super deep and really cold and kind of hard to get to, and two, because it's something that is an ice and then turns into a gas, it's like naturally hard to work with, because if it's already become a gas and it's just going to go all over the place, and then if you need to turn it into a gas, you need to heat it up, but it's highly flammable, and so your heat source might explode it. So it would be a tricky thing to drill. And so that's more of a fringe opinion, but it is something that...
it would explode, but doesn't like the entire like burning of it, like you have to heat it to burn it, don't you?
Yes, but you're heating a small controlled amount to burn it in a generator. If there's like a giant ice pocket of it, then that would be an explosion rather than, it's just like your car puts a little bit of gas in it once. This would be just lighting the whole tank on fire, which would probably be bad. So that's an issue with methane hydrate. People also talk about methane hydrate in the context of drilling for oil and gas, that you'll naturally accidentally find some methane hydrate, and you have to find a way to deal with it. This is particularly true with drilling in the Arctic, because, again, it tends to be more where things are frozen. So some people say if we drilled north of Alaska, we might release a whole bunch of methane, and then we would all either explode or die from global warming, and that would be bad. So, yeah, that's methane hydrate. Any more questions about that or any of the energy things? We're moving on from energy. Cool. All right, a few economic and political issues, or terms that you need to know about. First is SLOCs. S-L-O-C-S, SLOCs. SLOCs is shorthand for Sea Lines of Communication. Sea Lines of Communication. Given that there is so much trade that happens over the oceans, about 90% of trade that occurs, there is a sort of regimented system of where this trade goes. Given the way ocean currents work, given where ports are, given the depth of oceans, and given where straits are through various regions, there has formed sea lines of communication, which you can basically think of as giant ocean roads. The paths that the boats take to get to places. There is some concern about the preservation and expansion of sea lines of communication. a few very important ones that will certainly come up in your debates this year that are important parts of sea lines of communication. The Panama Canal, connecting the Atlantic and Pacific Ocean, is an important sea line of communication that prevents ships from having to go all the way around South America. The Strait of Malacca. Anyone tell me what country the Strait of Malacca is in?
Canada. I was gonna say Malacca.
Malacca. Is Malacca a country?
No.
There we go. Yeah. Yeah, Malaysia and Indonesia. And so it is a key form of trade. It's basically how all trade can go from the Indian Ocean to the Pacific Ocean. The Suez Canal connects the Indian Ocean to the Mediterranean. The Strait of Hormuz is another one you'll hear about, which basically connects the Persian Sea to the Indian Ocean. It's right next to Iran. And there's a bunch of speculation that exists about new Arctic shipping sea lines of communication opening. So Russia has begun building ports on its north shore, and those ports used to be inaccessible because of ice. But now, as more ice melts, there's basically more places you can drive boats. And so there are some conversations about Arctic shipping routes which could make things much quicker and faster, because the fastest line between the United States and Russia, for example, is north. It's not east or west. It's going over the Arctic. And so new sea lines of communication might open up. The reason why these are important is that you notice a lot of these are straits or canals: the Suez Canal, the Strait of Malacca, the Strait of Hormuz, the Panama Canal. These are relatively small areas. They are not that big, and almost all global trade has to go through one of these lines of travel. So for example, if the Strait of Malacca got shut down for some reason, if there were political instability or a naval war or pirates, then it would be disastrous for the global economy. So SLOCs, sea lines of communication, for the economy to function the way it does now, it's important that they be kept open. Next thing that is a political issue that needs a sort of discussion is the Law of the Sea Treaty. The Law of the Sea Treaty, which is also known as LOST, Law of Sea Treaty, or you'll also see it abbreviated in various literature as UNCLOS, the UN Convention on the Law of the Sea, UNCLOS. Law of the Sea. The Law of the Sea was basically an attempt by the UN to get everyone on board with one set of rules and regulations as to how the oceans work, basically. Who gets to drill what resources, who gets to drive which boat where, how we resolve disputes between those things, etc. The U.S. has never formally ratified the Law of the Sea Treaty. We're generally cool with all of this, but we're not going to say we're totally on board. But it's still very important in terms of the way economics work, because it contains within it two concepts that will come up a lot in the debate or reading that you do. The first is that of territorial waters. Territorial waters are out to 12 nautical miles from the coast. And within those 12 nautical miles, the country is allowed to set laws, regulate use, and use any resource. That's yours. That 12 miles, what happens in that 12 miles, that's... So that's really what you totally own.
Yeah, the coordination is
The other important concept of... Did we lose the camera?
Yeah, the camera.
Oh, no. Nailed it. That's fine. Another important concept related to this is what's known as the EEZ. The EEZ is something that the Law of the Sea created and named the Exclusive Economic Zone. Exclusive Economic Zone. These extend 200 miles out from the coast, and within that area, the coastal nation has the sole exploitation rights over all natural resources.
200 nautical miles or just miles?
Nautical miles. Just 230 real miles. I don't know why they're different. But 200 nautical miles. So what the EEZ basically means is that within 200 miles, your country is allowed to drill for stuff. Kind of no questions asked. Your country would be allowed to build OTEC there. No questions asked. Within 200 miles. Outside of that, you're in international waters and you need to sort of negotiate or figure out if you're able to drill for oil there. Now the reason EEZs are relevant is twofold. First, it determines where most of the affirmatives will probably take place if they're development acts. Most development will probably happen in a country's own economic zone, ergo within 200 miles of the United States. The second reason why EEZs are relevant is that because sometimes there are two countries that are both within 200 miles of something. And that means that a little conflict can happen. Two conflicts that you should know about related to exclusive economic zones. The first is in the Senkaku Islands. The Senkaku Islands are between China and Japan. Senkaku is Senkaku. They're between China and Japan, and they found some oil there, and they're within 200 miles of both China and China and Japan both want it. And so there are some concerns that if they both continue needing energy, that they'll fight over that. The Spratly Islands, which are in the South China Sea, Spratly is Spratley Islands. They're in the South China Sea, and they're within 200 miles of like basically everyone. There's just like Vietnam, Thailand, I think Malaysia has staked a claim, China has staked a claim. There were islands that are basically just piles of rock where no one really lives. But someone discovered oil under said piles of rock, and now everyone wants to live there, strangely.
Taiwan and Indonesia also.
Taiwan and Indonesia also? Yeah, okay. Yeah, so a bunch of different countries are saying those are our islands, and so there are disputes that need to be settled there. Last term that I'll talk about is climate refugees. Climate refugees. As sea level rises continue to happen, this has a devastating effect on people who live at low sea level. They have to go somewhere because the place they were before is under an ocean or will be under an ocean. And so there are a lot of concerns relevant to oceans about what we do when sea level rise happens and there are a bunch of people who are displaced from their homes. Where do they go? And that is a whole lot of people who would be, if scenarios for global warming and sea level rise play out like a lot of scientists expect, there would be a whole bunch of people who were displaced, and that would be devastating for them and the world and their lives. So sort of a survey of various terms, various issues, various potential affirmative ground that's going to come up. Real quick, I'll mention some things that will be negative ground. There's not a whole lot to say for this section, which might be a problem with this topic. There are critique arguments. Turner will talk about those. I'm not going to get into that. The topic paper suggests that negative positions can focus on international issues, especially with China or Russia, in regard to control of exclusive economic zones. Some negatives might take the route of environmental challenges. Additionally, there is a wealth of negative information focusing on the burden of additional exploration and development would place on the U.S. economy. So basically, the framers of the topic have said you get a budget disad, because it costs money to develop things. You get an environment disad, because at least some of those sorts of development are going to hurt the environment. And then you probably get some arguments or advocacies that someone other than the United States federal government should do the development or exploration. So the it's there being relevant. And then if it's an affirmative about energy, you have any disadvantage about a different sort of energy, because if the affirmative works and we have a lot of that energy, we use less of a different type of energy. So that's kind of relevant for neg ground stuff. But neg ground sort of develops the more we know about the topic. And I think my goal here is more to have you all know a diversity of things about the issue areas that are relevant and present. What questions do people have at this juncture? Yes?
So, would assisting in cleaning up pollution in the oceans work under exploration or development?
Maybe under development, but there would be a topicality debate about whether or not that pollution cleanup counts. That was a suggested topic paper was some sorts of pollution cleanup, so I think very likely if you developed a system of pollution cleanup, then that'd work. Yeah.
So like obviously like saving an animal species is not considered topical, so would killing one be like go to kill all the great white sharks to save or just go to kill all the great white sharks to give to the environment? Would that be a typical act?
Well, if getting resources is a form of development, so if drilling for oil is development, getting shark carcasses and whales probably also development. Your lab leaders.
Hey, wait, there's some announcements here.
Oh.
So there's 2 people are moving from Abby and Beavis lab to Ed and Stevens lab. Manav Daftari. Manav, raise your hand. You are in Ed and Stevens lab. And Quinn Lowry. Quinn, raise your hand. You're also in Ed and Stevens lab. Just even out the numbers. And we also developed a lab room. You all have to go into
you should check.
Right. So, obviously, Jason and Nick, you came for 101. Right now is lunchtime, but we can listen to the announcements.
Hey, y'all hold up real quick.
And Ed and Steven is Callaway S103. And S109. Callaway S109. Vernon is Annabelle 123. Vernon and I are candle 120.